understand where is this differentiation useful, then we'll understand what is the concept of differentiation. First of all, differentiation comes under the branch of calculus. Calculus is a mathematical broad concept, broad field which includes three topics. Limits, which we already studied, then differentiation, and it includes one more topic which is called integration. But that is not covered in your syllabus. That is a topic which even science students find difficult to absorb. So they are not included in commerce. Now, three topics are the limits, differentiation and integration. Limits we have studied, now we'll study differentiation. And differentiation is used in various fields of economics, like finding cost, revenue and profit. As a businessman in the economy, you are always interested in knowing the cost function, revenue function and profit function. Okay, so here we often come across the points like, if you increase the production, then how much would be the increase in cost, which is called as marginal cost in economics. Increase in cost due to 1 unit of production. Same way you are interested in knowing that if you sell one more unit or you sell X number of units, then your revenue will increase by what amount? Marginal revenue. Also, with respect to cost, you are always interested in knowing at how many units production the cost will be minimum. Because in economics you would have studied that long-term cost curve is always U-shaped. So at some point of time it becomes minimum. So you're always interested in knowing what is that point of time. How many units you produce, then your cost will become minimum. And you'll be interested in knowing at what number of units your revenue would be maximum. And also you'll be interested in knowing at what number of units your profits would be maximum. The answers to all these questions can be obtained by differentiation. Okay? What is the meaning of differentiation? Simply, differentiation means a technique to find. Differentiation is a technique to find change in Y due to change in X. Okay, we have been studying that X is independent variable and Y is a dependent variable. This we have been studying since first part of statistics when we started with correlation chapter. Bivariate data, that X is always independent and Y is always dependent on X. So differentiation is used in finding out what is the change in Y due to unit change in X. Like marginal cost, here Y is cost, X is number of units, and cost is dependent on units of production. So in marginal cost, we'll be interested in knowing what is the change in cost due to change in units. If you're finding marginal revenue, then Y becomes revenue. And marginal revenue means you'll be interested in finding what will be the change in revenue due to the unit change in units sold X. And same way, minimizing, maximizing profit, revenue, minimizing cost, all this concept can be used. But the meaning of differentiation is what? Change in Y due to change in X. And differentiation is actually a technique of finding this. Mathematical technique of finding the same. Change is generally denoted as delta, which for simplicity we will denote as D. Okay? Delta Y means change in Y upon delta X. Upon delta X means change in X. Delta means change. For simplicity, instead of delta, we will denote it as D. So dy upon dx. Okay. And Generally y is a function of x. This variable y is always equal to a function of x because it is dependent on the variable x. So y would be like 3x squared plus 4x plus y. Means y will depend on the value of x. So it will be a function of x. So either you call it as dy by dx or you also denote it as f dash x. Okay, fx is a function of x and f dash x shows changes in y due to changes in x. And you read this as derivative of y, dy, derivative of y upon dx means with respect to x. Dy upon dx is read as derivative of y with respect to x. Did everyone of you understand it? But the meaning is change in y upon change in x. So you can say that differentiation is a technique of finding change in y due to change in x, or you can say differentiation is a technique of finding derivative of y with respect to x. Both means one and the same. Is everyone okay with this? So write down meaning first. Differentiation is a technique of finding changes in dependent variable y, changes in dependent variable y due to changes in independent variable x. Full stop. Did you understand this? Full stop. This. It is a technique of finding changes in functional value of x, fx, changes in functional value of x, fx. Okay, y means fx. So it is a technique of finding the changes in functional value of x due to changes in x. Any confusion with this? So it is denoted as f dash x or dy by dx and read as derivative of y with respect to x. Read as derivative of y with respect to x. Did everyone of you understand this? Now, first we go with the definition and derive a formula to find this. Okay? So, how to find dy by dx or f dash x. Yes, what is going on over there? Vanshik, what happened? Using the definition itself. Understand how is this formula derived? See, suppose old value of x, new value is x plus h. So can I say that change in the value of x is h? Suppose the old value is x and new value is x plus h, means h shows the change in the value of x. Any confusion in this? Even if you do new value minus old value, you will get the change. So if you do x plus h minus x, then x gets cancelled. What is the change? H. Now y for old value will be fx, for new value will be f of x plus h. Any confusion in this? And change would be f of x plus h minus f of x. Now how can you find dy by dx or f dash x? Can I say it is equal to change in y upon change in x, as we discuss the definition right now? What is change in y? Fx plus h minus fx upon what is change in x? H. And this we have seen using the concept of limits already. Many questions we practiced with this. Limit h tends to 0, fx plus h minus fx divided by h. This formula will be used to find change in y due to change in x, derivative of y with respect to x. If in the question it is specified, that do it using the definition. Otherwise we'll use certain more formulas which we'll see tomorrow. But when they mention using definition, then we'll use that limits concept. Fx plus h minus fx upon h. When fx plus h minus fx shows change in y upon h shows change in x. Did everyone understand this portion? Any doubts with it? So this is the main formula which you have to remember. Write it down. If you want to know the method, you can write it. Otherwise, you may directly write the formula. In summary, other than this, you'll need two sides. So everyone is clear with the definitions formula. If you go with the definition, the formula to find dy by dx is limit h tends to 0, fx plus h minus fx divided by. Now all these examples we have practiced in limits, so it's just a revision of limits, consider it. And in solving this fx plus h minus fx, when the power is given x raised to something, or cube root or square root or nth root of x, then you can convert x plus h into t and use the magic to solve it. Okay, n a raised to n minus 1. So once we solve it, you must be able to differentiate when to convert x plus h into t and when not to. Okay, that you must be able to differentiate in the question. So look at question 1 on page 173, exercise 5.1. See, obtain the two sides. Obtain the derivatives of following functions underlined with the help of definition. Okay, it is clearly given with the help of definition. First one, fx equals to 2x plus 3. Since plus 3 is given, further 2x is given, will not use the concept of magic. Simple concept will only be used. So what will be fx plus h? 2 in place of x we will put x plus h plus 3. 2x plus 2h plus 3. Right now? Did you understand this? When to substitute x plus h equals to t if it was given x raised to 5, or if it was given 7th root of x, x raised to the power something, power is required, then only we convert it into t. Is everyone clear with this? Now, we need to find f dash x. So, limit h tends to 0, fx plus h minus fx upon h. Okay. So limit h tends to 0, Now what will we write in place of fx plus h? 2x plus 2h plus 3 minus what will we write in place of fx? 2x plus 3 divided by h. So limit h tends to 0, but write that second in bracket because it's minus. So when you open the brackets, the signs will change. So 2x plus 2h plus 3 minus 2x minus 3 divided by h. Now 2x minus 2x gets cancelled. 3 minus 3 gets cancelled. What remains is limit h tends to 0, 2h upon h. Again h gets cancelled. Answer is simply 2. So same thing what we practiced in the last chapter. It means change in y due to change in x will be 2. If x changes by 1 unit, y will change by 2 units. Did you understand this portion? Look at question 2. Fx equals to x square. Now can we use t? X square. So here we will use the concept of t. As I said, if the power is there, then you can use the concept of t. So very first of all, fx plus h will be x plus h whole square. Don't take a square plus 2ab plus b square formula. As I said, we'll do it in a more simple manner using the formula of magic. So we'll say let x plus h equal to t. So h will be equal to t minus x. Now we'll find f dash x. Limit h tends to 0. Fx plus h minus fx upon h equals to limit h tends to 0. In place of fx plus h, we'll write x plus h whole square. In place of fx, we will write x square upon h. And now x plus h we will take as t. So when to substitute t, everyone is clear? Okay, this same thing we studied in limits also. Limit h tends to 0. Now it will become t square minus x square upon t minus x. X plus h will become t square minus x square upon h will become t minus x. Now n raised to n minus 1, what is n? 2a x raised to n 2 minus 1. So simply 2x. Did everyone understand this? Any doubts on it? So now I will be asking you the remaining questions. Means if x changes by 1 unit, then fx or y will change by 2 times of that, 2x units. Here's what happened over there. You don't want the fan. Who all want that fan? Yes, now further. Question number 3. Fx equals to x raised to 7. All of you are clear with this? When to do this t, everyone is able to identify? Then, Divyajit?
f dash x is equal to fx plus h.
First of all, limit h tends to 0.
Fx plus h minus h upon h.
Yes. Limit h tends to 0. Fx plus h minus fx upon h. Okay. X plus h will be x plus h raised to 7. So x plus h is taken as t. H will be t minus x. Now f dash x is limit h tends to 0. Fx plus h minus fx upon h. Then Palak. Limit h tends to 0. Fx plus h is x plus h raised to 7. Fx is x raised to 7. upon h. Then Khushali,
Limit h tends to 0.
limit h tends to 0. Who is talking in between?
T raised to 7
X plus h we have assumed as t, so t raised to 7
minus x raised to 7
minus x raised to 7
upon t minus
and
h.
h is t minus x. And then Megha,
7
n is 7,
is
a is
x
x,
raised to 7 minus 1.
n minus 1, so 7 minus 1 means 7x raised to 6. So this is change in y due to change in x. Did everyone understand this? Question 4. fx equals to 1 upon x plus 1. Rushan,
fx equals to f of x plus h equals to
f of x plus h equals to
1 upon x plus h plus 1.
yes, in place of x we'll put x plus h plus 1 as it is. Will we take t? Now we'll not take t. As I said, t you will take only when there is some power. Here simple simplification is to be done. So directly we'll apply the formula. Meet f dash x is equal to limit h tends to 0. Yes, silence everyone. fx plus h minus fx upon h. Silence everyone. Yes, further. Limit h tends to 0.
1 x plus 1 upon x plus h plus 1 minus 1 upon x plus 1
Upon h. In fx plus h we will substitute 1 upon x plus h plus 1 minus in fx we'll substitute 1 upon x plus 1 upon h. Now in numerator first of all we'll find the LCM. Pooja.
X plus 1 will be common.
No.
X plus 1 minus 1 upon
X plus 1 is not common. It is not x plus 1 into h. If it is x plus 1 into h, then x plus 1 is common into h, would be the LCM.
H minus
Yes.
H minus
Asta. No. Yes, raise your hand and tell me the LCM. Khushbu? Then? Very good, correct. It is very, very simple. The LCM is, silence everyone, x plus h plus 1 into x plus 1. This is the LCM. And cross multiply. X plus 1 into 1, x plus 1 minus 1 into x plus h plus 1, x plus h plus 1. And divided by h. Is everyone clear with this? Anyone having any confusion with the LCM, raise your hand. Okay, x plus h plus 1 into x plus 1 is the LCM, and cross multiply x plus 1 into 1 x plus 1, x plus h plus 1 into 1 x plus h plus 1. That equals to limit h tends to 0. Now open the bracket, so x plus 1 minus x minus into plus minus h minus into plus minus 1 upon x plus h plus 1 into x plus 1. Now can I say divide by h means into 1 upon h? divided by h means multiplied by the reciprocal 1 upon h. Is everyone clear with this? Now in the numerator, Neil, what all will get cancelled? Padil?
X and 1.
X minus x gets cancelled, 1 minus 1 gets cancelled. What remains is minus h upon x plus h plus 1 into x plus 1 into h. And now h also gets cancelled. So limit h tends to 0, minus 1 upon x plus h plus 1 into x plus 1. Now we'll put the value in h. Now when you put the value in h, what will you do? Limit will not be written. So simply minus 1 upon x plus 0 plus 1 into x plus 1. That is minus 1 upon x plus 1 into x plus 1. That is minus 1 upon x plus 1 whole square. So if x changes by 1 unit, then y will change by minus 1 upon x plus 1 whole square value. Did you understand this portion, everyone? Further, question number 5. Fx equals to cube root of x. Now, Brunda, further, fx plus h will be cube root of x plus h. In place of x, we will put x plus h. Then, no. Here we will take t. I told you whenever there is a power, cube root means what is the power? 1 by 3. Then you have to assume x plus h as t. So now we will take let x plus h equals to t. So h will be equal to t minus x. Okay, remember this, whenever there is the power you have to assume this. Now, Rishabh, f dash x, limit h tends to 0, then fx plus h minus fx upon h. Silence everyone. Yes, further. Limit h tends to 0. No one should be prompting over there. Cube root. What is fx plus h? Fx plus h is cube root of x plus h. Further, minus fx is cube root of x on h. Sit down. Is everyone clear with this? Then, Kushi.
Limit of h tends to 0, t raised to 1 by 3.
Yes, first of all x plus h will take as t, and cube root means the power is 1 by 3.
Minus x raised to 1 by 3.
Minus x raised to 1 by 3
Upon t minus x.
upon t minus x. Is everyone clear with this?
Yes, sir.
Now if we apply the formula Swara, Disha?
1 by 3 x raised to 1 by 3 minus 2.
Yes, Swara, what is the confusion? N is 1 by 3. We have done so many questions in limits like this. N is 1 by 3 into a is x raised to n is again 1 by 3 minus 1. Now, what is this 1 by 3 minus 1? Minus 2 by 3. 3 into 1 will become 3. And what is 1 minus 3? Minus 2. So x raised to minus 2 by 3. And minus means you will bring it in the denominator. So 1 upon x raised to 3x raised to 2 by 3 is the final answer. Did you understand this, everyone? Now question number 6. Anyone still solving the 5th question? Raise your hand. Let's look at 6th question now. Fx equals to 2 upon 3x minus 4. Jeeted?
So fx plus h is equals to 2 divided by 3x plus h minus 4.
Yes, in place of x, we will put x plus h. 3 into x plus h minus 4. That is equal to 2 upon 3x plus 3h minus 4. Okay, if you open the brackets, 3x plus 3h minus 4. Then, Shrushti? Now here no t. Okay, there is no power. So here we cannot assume it as t. Normal simplification is to be done.
F of x plus h minus f
First of all, limit h tends to 0. Yes, fx plus h minus fx upon h. Further,
2 upon 3x
now fx plus h is 2 upon 3x plus 3h minus 4. Minus fx is 2 upon 3x minus 4 upon h. Is everyone clear with this?
Yes.
Pooja, next.
2 into 3x minus
Limit h tends to 0. First of all, in the numerator, what will be the LCM?
3x plus 3h minus 4 into 3x minus 4.
Okay, 3x minus 4 is not common. In between, plus 3h is also there. So 3x plus 3h minus 4 into 3x minus 4. Now,
2 into 3x minus 4
2 into 3x minus 4
minus 2 into 3x plus 3h minus 4
minus 2 into 3x minus 3h minus 4 whole divided by h. I repeat it, be attended. LCM is 3x plus 3h minus 4 into 3x minus 4 and you cross multiply. 2 into 3x minus 4 minus 2 into 3x plus 3h minus 4 and whole divided by h. Any confusion in this? That is equal to limit h tends to 0. Ravlani?
6x
2 into 3x, 6x. 2 into minus 4, minus 8.
minus 6x
Minus 2 into 3x, 6x.
minus 6h
Minus 2 into 3h, 6h.
plus 8.
And minus 2 into minus 4 plus 8.
Then
Upon 3x plus 3h minus 4 into 3x minus 4, what else?
upon whole h.
No, into 1 upon h. Okay, divide by h means now we will write into reciprocal 1 upon h. Is everyone clear with this? Gina, what in numerator gets cancelled?
3x
this one.
6x
6x minus 6x cancel,
and 8.
and minus 8 plus 8 cancel. Tell me what will remain. Limit h tends to 0.
Minus 6x
Minus 6h
upon 3x plus
upon 3x plus
3h
3h
minus 4.
minus 4
3x minus
into 3x minus 4 into h. Now h will also get cancelled. So what will remain is limit h tends to 0 minus 6 upon 3x plus 3h minus 4 into 3x minus 4. Is everyone clear with this? Then David,
In place of x, we will substitute h.
yes, in place of h we'll put 0, so minus 6 upon
3x plus 3 into 0 minus 4 and 3x minus 4.
into 3x minus 4. In place of h we will put 0. So minus 6 upon 3x minus 4 again into 3x minus 4. That is minus 6 upon 3x minus 4 whole square. Did everyone understand this? And seventh, fx is equal to 10. Anyone still writing up till here? Raise your hand. Completed? Akansha? Now be attentive. If fx is 10, very instantly you can say that if fx is a constant number 10, means is it dependent on x? No x is given on the right side. Like x squared, 10x. If 10x was given, then you can say that y is dependent on x. Now it is a constant number 10. Means whatever values you put in x, y would remain 10 only. So y is independent of x. So without solving it, what would be the change in y if x changes? No changes would take place. Means your answer should come 0. Okay, whenever it's a constant number, then change in y due to change in x will always be 0. Like fx is 10, so even fx plus h would be 10. And then you'll say f dash x equals to limit h tends to 0 fx plus h minus fx upon h. So limit h tends to 0. Fx plus h is also 10 minus fx is also 10 upon h. Limit h tends to 0. 10 minus 10 is 0 upon h. That is finally 0. Whenever fx is a constant number, then change in y will always be 0. It will not be affected by the changes in x. Did everyone understand this? In exercise 5, only one question I have to do. That too because of the constants a and b used over there. Otherwise it's a simple one. Page 197. Exercise 5, section D, question 1. See, y equals to ax plus b where a and b are constants. Underline using definition. You will find the derivative of y using the definition. First of all, y means we can write it as fx equals to ax plus b. So what will be fx plus h? A into x plus h plus b. In place of x we will substitute x plus h. Now if you open the brackets, ax plus ah plus b, f dash x equals to limit h tends to 0 fx plus h minus fx upon h is equal to limit h tends to 0 ax plus ah plus b. Fx plus h is ax plus ah plus b minus fx is ax plus b, but we'll write it in bracket upon h. Now if you open the brackets, ax plus ah plus b minus ax minus b, minus into plus will become minus. Ax minus ax cancel, b minus b cancel. So limit h tends to 0, ah upon h, h cancel, final answer is simply A. Did everyone understand this? Second and third, take it as homework, they are very simple ones now. And illustration 1 to illustration 6 is your homework. Illustration 1 to illustration 6. 1, 2, 3, 4, 5, 6. Okay, TO2. Now, listen everyone. Without the definition, understand this portion everyone? Two things to be understood, then we'll see the working rules for differentiation. Without the definition, you can say dy by dx. Everyone be attentive. Dy by dx if, first of all, y equals to function of x, which is x raised to suppose n. Then dy by dx, that is f slash x, will be equal to, directly you can say nx raised to n minus 1. For example, on page 173, third question, fx equals to x raised to 7. What final answer did we get? 7x raised to 6. Even if we would have not done those 9-10 steps and directly done nx raised to n minus 1, then n is 7, x raised to 7 minus 1, 6. Straight away you would have obtained that. Now in the remaining part of the chapter, when we do it, we directly write 7x raised to 6. We will not do those 9 to 10 steps. So this you remember as the concept without the definition itself. First we did with definition and understood, we get that answer. Now without the definition, directly remember, if y equals to fx equals to x raised to n, if function of x is x raised to n, then dy by dx will be directly nx raised to n minus 1. And second thing you remember, which again we understood in the last point, that if function of x is a constant number, if function of x is a constant number, then dy by dx will be 0. Is everyone clear with this? Write it down. Did you understand this 2 points without definition, what we have to remember? If y equals to fx equals to x raised to n, then dy by dx will be directly nx raised to n minus 1. And if y equals to fx equals to k, a constant number, then dy by dx will be equal to 0. Now 4 working rules of differentiation we have to remember. Be attentive. and you'll remember them without any proof. How they are obtained? It is given in your textbook itself that these are the 4 working rules without any proof. So directly you will remember them as formulas. First one is if y equals to u plus v. U plus v means u can be any number with x or without x. It can be 5x square. It can be only 3x. It can be only 5 also. Same way v can be 2x cube, 8x raised to 7. It can be anything. It can be 5 also, constant number also. So if y equals to u plus v, then dy by dx will be equal to dy by du plus, du by dx plus dv by dx. In fact, plus minus. If it is minus, then you use the sign minus. If it is plus, then you use the sign plus. Okay, just to make you understand it, suppose y is equal to 3x square plus 4x cube. Then can I say this is u and this is v? So what will be dy by dx? Du by dx plus dv by dx. Now du by dx means, can I say 3x square will be 3x, 3 into 2, 6x raised to 2 minus 1. 3 into 2 it will become 6x raised to 2 minus 1 means only 1. And 4 into 3, 12x raised to 3 minus 1, that is 2. This is the final answer. So u is any number with or without x, and v is any number with or without x. Suppose you have plus minus w also, then what you will do? Plus minus w also, then plus minus d of w upon x. Suppose you have plus minus w, let us say 5. Now we know constant numbers differentiation is 0. So simply plus 0. Okay, so if y equals to u plus minus v, then du upon dx plus minus dv upon dx. First, to differentiate u with respect to x, apply the formula lx raised to n minus 1, or if it is a constant number, then directly take 0. Then you differentiate v with respect to same formulas and add or minus whichever sign is used. Now this was just for the first one, others will directly write. So if y is equal to u into v, product of two numbers, then remember dy by dx equals to, now listen everyone how you should remember it is du by dx, everywhere dv by dx, this remains constant. This you multiply with v, this you multiply with u, multiplication will become plus. Everywhere first you write du by dx and dv by dx. Now du by dx you cross multiply with v, and dv by dx you cross multiply with u, and multiplication becomes plus. If y is equal to u divided by v, then again you remember, as I said, be attentive. First you do du by dx, then you do dv by dx, du by dx multiplied with v, du by dx multiplied with dv by dx multiplied with u, because division put minus upon v square. So in textbook they are writing the formula u into dv upon dx plus v into du upon dx, but you write it this way. Final answer will come C. It is easy to remember that in all the rules you will write du upon dx, dv upon dx. When it's plus minus, simply plus minus. When it's multiplication, then cross multiply v into du upon dx, u into dv upon dx. When it's division, then again cross multiply v into du upon dx, but division will become minus. U into dv upon dx whole upon v square. And if y equals to u raised to n, where u is a function of x. Y is not directly a function of x, but y is u raised to n and u is some function of x. Means let us say u is 2x plus 7. U is 2x plus 7 and n power is 9. Then you will apply this rule. 2x plus 7 whole raised to the power 9. So 2x plus 7 is a function of x that you will take as u. And then you will apply the formula dy by dx equals to, first you will differentiate y with respect to u and then u with respect to x. dy by du into du by dx, which is also called as chain rule. Last one is also called as chain rule. Okay, so this 4 you have to write 20 times. So that when we solve the questions, confusion doesn't arise. Based on that, we'll take up the questions tomorrow. But they are very simple rules. Once you solve it, you will realize that. That'll be all for today. Bye everyone.